Today we're going to talk about how to determine whether a function is an even function, an odd function, or neither an even nor odd function. To complete this problem, we'll substitute negative x for x, simplify, and then see whether our result is equal to our original function, an even, equal to our original function times -1, an odd, or neither. In this particular problem, we've been given three separate functions and asked to determine whether each one is an even function, an odd function, or neither. To make this determination, in each case we'll plug in negative x in place of x to our functions, simplify, and then the result will tell us whether the function is even, odd, or neither even or odd. Let's go ahead first and plug in negative x to our first function. We'll get negative x to the fifth plus negative x, and again we just want to simplify as much as we can here. Negative x to the fifth will give us negative x to the fifth like this, minus x. At first glance, this might not look the same as our original function, f of x, but if we factor out a negative sign, we'll get negative x to the fifth plus x, and we can see that our functions are the same, but for the negative sign out in front. We have in our original function, x to the fifth plus x, and in our simplified function here, x to the fifth plus x, the only difference here is this negative sign. As you can see, since we know that f of x is equal to x to the fifth plus x, we could just as easily substitute f of x for x to the fifth plus x, and you can see that we get negative f of x. That's exactly what we were looking for to determine that this is an odd function, so we know here that we have an odd function. We'll go ahead and do the same thing with our second function. As always, we'll plug in negative x in place of x, and we'll get 1 minus negative x to the fourth. When we simplify this, we'll get 1 minus negative x to the fourth will give us a positive sign. That negative sign inside the parentheses will go away, and we'll just be left with x to the fourth. As you can see really quickly, we're right back where we started at f of x. So this just becomes f of x, and as you know, when we get back to our original function, f of x, we know that that's an even function. We've defined these down below, by the way. We can see that if we get back to f of x, we have an even function. If we get to negative f of x as we did in the previous problem, we have an odd function. And then when neither of those things is true, we get neither even nor odd. Let's go ahead and look at our third function. Again, as always, we'll plug in negative x for f of x. That's always how, negative x for x. That's always how we make our determination of even, odd, or neither. So we'll see that we get 2 times negative x minus negative x squared. We'll simplify this as much as we can, and we'll get negative 2x minus this negative x squared. That negative sign inside the parentheses will go away, and we'll be left with x squared. As you can see, this isn't equal to f of x. They're exactly the same except for this negative sign out in front of the 2x here. But we didn't get f of x exactly, so we can't call it even. Even if we try to factor out a negative sign and we get negative times 2x plus x squared, we still don't have our original function here because our original function is 2x minus x squared, and we have 2x plus x squared, so we can't call this odd either, which means this is going to be neither. And that's it. That's all there is to it when it comes to determining whether or not your function is even, odd, or neither even nor odd.